Everyone, today I'm going to share you again about solving question in paper 2. This is from student worksheet. Yeah. Uh, let us start about number 1 and so on. Define force. Yeah. The first question is define force. Force as the change in momentum over time taken. Yes, correct. Or force equals to delta P over delta T. Yeah. Also force, unit force is Newton. Also same thing with delta momentum over times is equal to kilogram meter second minus 2. Yeah. So the big question when they have question as the set the SI base unit of force, yes, Newton, and in base unit SI as the kilogram meter second minus 2. Or you can imagine with force as the Newton second law, yeah, that's force equals to mass time acceleration. So we have base unit SI of mass and acceleration as the kilogram meter second minus 2. Yeah. Yes, this is base unit of force. Yeah. So see question, the first F between 2 point charge is given by F as the Q1 times Q2 divided by 4πr square time epsilon. Yeah, this is epsilon. I want to, yes. Yeah. This is actually electrostatics or Coulomb's law. Yeah, when the object has charge. Yeah. And then they have uh, attraction or repulsion force, yeah, between them. So where Q and Qi and Q2 are the charge, R is distance between the charges, yeah, and epsilon is a constant that depends on medium between the charge. Use the above expression to determine the base unit of E, yeah, or epsilon. So this is actually the constant that depends on the medium we call as the permittivity. Yes. So if we change equation on this equation, F equals to Q1 Q2 divided by 4πr square E. So we can say E as the Q1 Q2 divided by 4πr square F. So from this equation we can find the base unit of epsilon, base unit of E. Yes, Q1 and Q2, Q equals to IT actually, yeah, that's Q equals to current times time. So we can say here as the ampere second and also here also ampere second, and divided by 4 pi. 4 and pi, this is constant, they have a unit, yeah, and r as the distance, meter, yeah, meter square, and force, yes, force equals to what I mentioned before as the kilogram meter second minus 2. So totally after we scraping, yeah. Yes, base unit of epsilon as the kilogram minus 1, meter minus 3, second 4, and ampere square. Yes, this is about electrostatics or Coulomb's law. This is about permittivity. Yeah, that constant depends on medium between the charge. Okay, we continue again. Number two. Number two, the question on A as the state the principle of conservation of momentum. Yes, momentum is conserved, yeah. Or we can say total momentum before and after collision is same, yeah. Or momentum before equals momentum after collision. This is as we call it as the momentum conserved if two object collision or anything object broke here. Okay, this is about conservation of momentum states, and we continue on this figure here. We have figure 2.1. Yes, you can see here a stationary firework explodes into three before fragments that move in a horizontal plane as illustrated in figure 2.1. Yes, I think this is okay. No, wait, this is yes, this is wrong. In figure 2.1, we saw that particle has velocity for first condition and they have mass as 3.0 m and has velocity 7.0 meter second minus 1, yeah, and go to vertical up, yeah, go up vertical go up and explode into explode uh, no one this is one fireworks, yeah, explode into three different and two different has angle or has direction as the theta angle to the horizontal AB, and the mass for the particle here is as the 2.0 m and velocity 6.0 meter second minus 1. And in other particle, yeah, the third particle has mass 1.5 m and velocity a little bit high as the 8.0 meter second minus 1. So mm, yes, this fragment, yeah, has for fragment 2.0 m has angle theta. Also for fragment 1.5 m has angle theta to the line horizontal AB. So the question is, yes, use the principle of conservation of momentum to determine theta. Okay, we see this, yeah, about the conservation of momentum. Momentum after equals to momentum before, yeah. Yes, and the momentum has direction, so we can include the positive of negative direction as the calculation on our solving question. Yeah, this is 3.0 times 7 uh, with this point, yeah, this fragment of mass 3.0 times 7o, yes, and equals 2.0 m times 6.0 as the fragment here, but times with sine theta, yeah, because we see on the vertical sine, so vertical sine like something with sine of theta. Also the fragment of 1.5 meter, 1.5 m, yeah, times with 8 and times again with sine theta. So after we calculate, this is to 21.0 equals to, this is 2 times 6 equals to 12, and here is 1.5 times 8 equals to 6, yeah, 6, oh my god, this is 12 plus 12, 12 plus 24, yeah, 24, yeah, 24. Yes, this is 24 actually. Yeah. 24 sine, yes, we get theta around 48.5 degree as the sine theta as the 21 divided by 24. Yeah. Okay. So, other question, calculate the ratio kinetic energy of fragment of mass 2.0 m and kinetic energy of fragment of mass 1.5 m. Yeah. Yeah, we actually only dividing this mass and velocity in this ratio. Yeah, a half of 2 times 36. Yeah, 36 equals actually this is about 6 square. Yeah, and divided by a half of mass 1.5 m times with 64. This is 8 square. Yeah. So we get the number as the 0.38. This is the ratio between kinetic energy of fragment mass 2.0 and 1.5 m. Okay, continue to other question. Number 3. Number 3 about wave. Yeah, let you see about the wave. See in glance here. Yes. 3A1, 3AI, yeah, define the wavelength of a progressive wave. Yes, this is distance between two peak of wave, yeah, or distance between two maximum of wave, maximum amplitude of wave, yeah. Then state what it's meant by an antidot of the stationary wave. Yes, this is spot position when maximum amplitude. Yeah, antinote is yes the when the amplitude maximum. Yeah, that the position of the antinote of a stationary wave. Okay, B question. Yes, here. A loudspeaker producing sound of constant frequency is placed near the open end of a pipe as shown in figure 4.1. Yes, they have pipe, yeah, and speed of piston has 0.75 centimeter minus 1, and loudspeaker in distance x with piston. A movable piston is at distance x from the open end of the pipe. Distance x is increased from x equals 0 by moving the piston to the left with a constant speed of 0.75 centimeter per second. The speed of sound in the pipe is 340 meter second. Yeah. Okay, we have some question here. I will strike out. Mm, okay, a much louder sound the first heard when x equals, oh sorry, when x equals to 4.5 centimeter. Assume that there is an antinote of a stationary wave at the open end of the pipe. Wow. Yes. Determine the frequency of the sound in the pipe. So if we see the x actually for the hertz, for the first hertz, yeah, for the first hertz is equals to a fourth of lambda, yeah, a fourth of wavelength. X as the a fourth of lambda, so we can say uh, a fourth of v over f. Yeah, lambda same with the velocity divided by frequency. So velocity is 340 meter second and divided by f. So we can say uh, the x actually in meter is 0.045. Yeah, by dividing by with 100. So we get frequency as the 1889 hertz. Okay, this is about the first hertz. Yeah, when the first hertz equals to a fourth of lambda, and the second hertz is 3 over 4 lambda. For the third hertz is the 5 over 4 lambda. So the pattern is 1 over 4 and then 3 over 4 and then 5 over 4 and then 7 over 4 times with wavelength. Okay, we continue. After time interval, a second much louder sound is heard. Calculate the time interval between the first louder sound and the second louder sound being heard. Yeah. Yes, as I mentioned before, the x after the first heard as the 3 over 4. The second maximum we heard the sound as the 3 over 4 lambda. And lambda we already know, but lambda is v over f. So 0.135 we get this here from V is 340 meter second and frequency is the first frequency is 1889 hertz. So we get the x or distance x, the second distance is 0.135 in meter, yeah, or in centimeter is 13.5 centimeter. Okay, the interval time, same thing with the distance divided by velocity of piston, yeah. So when they have x as the uh, uh, distance between x2 and x1, so we can say 13.5 minus 4.5, yeah, the x after that. And because interval time we needed to find divided by velocity of the piston. Velocity of the piston is 0.75. So we get number 11.33 second. Okay. Yes, continue number 4. Yeah. Oh yeah, if you want to see here, yeah. See again the explanation of this solving question. Okay, I need to you to subscribe my YouTube channel. Please give me comment on the below column. Yeah, please comment if you have something find about the mistake or anything else. Okay, question 4. AI. State Kirchhoff first law. Kirchhoff first law. This is about the flowing of current. Yeah, the flowing of current is must be same. Yes, total current into junction equals to total current out of junction. It must be same. Yeah. I input equals to I output. Okay, question I. Kirchhoff's first law is linked to the conservation of a certain quantity. State the quantity. The quantity is charge. Why charge? Yes, because charge depend on current times t. Yes, so we can say the conservation of the certain quantity is charge. Okay, B question. A battery electromotive force EMF has 8.0 volt and internal resistance 2.0 ohms is connected to resistor X and Y wire as shown in figure 6.1. Wow, we have a diagram like this one. Whoa, okay. We see the diagram first. Yeah, this is EMF actually. 8.0 volt with inner resistance as the 2.0 ohms, and this is 2.5 ampere here, and parallel with this EMF resistor of X 15 ohms, yeah. And here wire Y, where Y as the RY. Yeah, I think we have some question below. Oh, oh my God. The resistance of X is 15 ohms. The resistance of Y is Ry. The current in battery is 2.5 ampere. So calculate question 1. The thermal energy dissipated in the battery in a time 5.0 minutes. Okay, we have, yeah, okay, we know the energy. Energy, they have three kinds of formula, yeah, as the VIT and V square over R times T, and we have that we use this expression as the E square RT. So we can say this is E as the 2.5 here square times 2 and times 300. Okay, we get, after we calculate this number, we get 3,800 joules. Okay, this is thermal energy dissipated in battery in time 5 minutes. Yeah, 5 minutes and with the 300 second. So we use this as 300 second. What about 2? Yes, 2 is in ohm. Yeah, because the question is thermal energy dissipated in the battery. The battery has inner resistance as 2.0 ohms, yeah, in 5 minutes. Okay, we go to other question. Wow. Question 2. Uh, I open all the, yes. Question 2. The terminal potential difference of the battery PD. Okay, we go here first. Yes. This is 8.0 volt and they have current as the 2.5. They cross to the 2.0 ohm. So we get the potential difference in 2.0 ohm as the 2.5 times 2. Yes, 5. So because this is the direction of the current as the opposite with the direction of it for, so we can say the potential difference uh, between the battery is 8 minus 5. 8 minus 5 is, yes, 3.0 volt. Yeah, this is as the terminal potential difference on the battery. So we will use 3 volt to determine the resistance of Ry. Okay. Now, in terms of determine the resistance Ry, we need to find the Iy first. Yeah, yeah, we don't know about I current in the wire. So the current in the wire we can find by Kirchhoff's law, that current into junction equals to current out of the junction. Into junction equals to 2.5, and the out of the current is Ix and Iy. Ix as the potential difference of this battery, because this is parallel. Yeah, same thing with potential on the 15 ohms. Yeah, so we can say I on the X resistance as the 3 volt divided by 15 by Ohm's law. So 3 divided by 15 equals to 0.2. Yeah, 0.2 ampere. This is Ix. Okay, Iy is, yes, 2.5 minus 0.2, because this is 2.5 coming into junction here and splitting into y two ways. Here is Ix as the 0.2 and Iy. So Iy as the 2.5 minus Ix equals to 2.5 minus 0.2. So Iy as the 2.3. Yeah, yes, this is 2.3. So finally we get the Ry back again to Ohm's law. Ohm's law as the V divided by I. So V equals to potential difference in battery as the 3.0 volt, and Iy as the 2.3, and we get 1.3 ohms. Okay, we finished about this question. Thank you very much for watching my screen video. Don't forget to subscribe, please. Subscribe, please. Subscribe. Thank you very much, and see you in other videos.